SwayamPrabha. Digital India. Educated India.
Welcome. We will continue with factorial experiments. Factorial experiments. In last class, we have discussed two-factor factorial experiment. And we discussed the main effects A and B, interaction effects A B, then how to compute their computation of main and interaction effects ME and IE. We have discussed also that there may be k factors and then k number of main effects and k C2 number of two-way effects, k C3 number of three-way effects. So, like this. In addition, for a two-factor factorial experiment, I have shown you that how the regression model can be developed. And then I have given you one example of factorial experiment with two factors. A experiment hypothetical data was shown to you, and in general what will be the layout for the data table or the data table also shown to you. In this lecture, what I will do, I will give you some statistical analysis of the experimental data and show that we will see whether the model is able to capture the variability in the response variable and accordingly able to determine also whether the factors main and interaction effects are really contributing in explaining the variability of the observed y or the response variable. So, in general there will be your general observation y I j k, I for ith row treatment, j for jth column treatment and k for replication. Okay. Then also we have seen that this y I j k equal to mu, that is grand mean, plus tau I, that ith row effect treatment effect, beta j jth column treatment, that is the column treatment effect, plus tau beta I j interaction effect, plus epsilon I j k, that is what is the error term, and this is what is our fixed effect model. This is what is our fixed effect model. And we have set hypothesis with reference to A. We say H0 that tau 1 equal to tau 2 dot equal to tau A, and H1 we say tau I not equal to 0, tau I, tau 1 tau I this equal to 0 and tau I not equal to 0 for at least one tau I. Similarly, for B we put H0 beta 1 equal to beta 2. So, like this equal to beta B equal to 0 and H1 beta j not equal to 0 for at least one j. And another one for AB we put H0 that tau beta I j this equal to 0 for all I j combination, and H1 we say that tau beta I j not equal to 0 for at least one I j. That is what we have seen in the last class. So, now given the table we want to compute Given the table means given the table of data or the observations assumed, we want to compute the different parameters or statistics related to the experimental data. So, y I dot dot, this is basically the row total, ith row total. Y dot j dot, this is the column total, jth column total. Y I j dot, this is basically the that row column combination, that is the cell total, and y triple dot, this is the grand total. Okay. So, with reference to our data, what is this? We have 1 2 like 8 rows, 1 2 like B columns, we have here ith row, we have here jth column. So, this is y I dot, that is basically row total. This will give you y dot j column total, and then y dot dot dot. So, y dot dot dot, this is your this is I dot dot I dot j I dot j dot, this is your grand total, this is related to row total. So, the first one will be y 1 dot dot, y 2 dot dot, something like this. Similarly, here y dot 1 dot, and this way grand total. And then you can calculate row average, which will be the general one will be y I dot dot average. You can calculate column average, which is general one dot j dot this average, and you can calculate grand average y dot dot dot, this is your grand average. So, then what will be the formula for your y I dot dot, this total? This basically going from column wise from 1 to b. So, sum of j equal to 1 to b y I j and k. So, definitely k will also be there, k equal to 1 to n, and I equal to 1 to a. Similarly, for column case y dot j dot, this will be your k equal to 1 to n, j equal to I equal to 1 to a, y I j k. Okay. So, this is the total. Now, what will be the average? So, y 1 dot dot y I dot dot average will be y I dot dot this total by b into n, total by b into n. What will be the this average? Column average, this will be y I j dot divided by a n. So, what will be the grand average? Grand total? Grand total will be all three sum y I j k, and then grand average will be y grand total divided by a b into n. Okay. So, this is the computation of different averages, row average, column average, row total, column total, grand averages, and this is what is given here in the slide also, y I double dot, y dot j dot, y I j dot, like this. Okay. One more thing I am not giving here, that what will be the y I j dot, y I j dot. This is nothing but the y I j dot, this is nothing but you have n observation k equal to 1 to n y I j k, that means the cell total, and then the cell average I j dot, this will be cell total divided by how many observation you have counted there, n observation counted there. Okay. So, this will give you the required statistic values for computation of SST, sum square total, sum square effect, main effects, interaction effects and errors, all those things. Okay. So, now I will show you the partitioning the variability observation I, j, k. It can be subtracted by its mean component. This can be written like this: y I dot dot bar minus y triple dot bar, plus we can write this as y dot j dot bar minus y triple dot bar can be written, plus we can write that y I j dot minus this bar minus y I dot dot bar minus y dot j dot bar plus y triple dot bar, plus we can write y I j k minus what is there y I j dot bar. Then this left hand side and right hand side will become equal. So, this and this will cancel out, this and this will cancel out, this will cancel out, this and this will cancel out, this and this will cancel out, then this side and this side will be same. So, this is known as partitioning the observations. So, you can square it, take sum over I j k, take sum over I j k, k equal to 1 to n, j equal to 1 to b, I equal to 1 to a, k equal to 1 to n, j equal to 1 to b, I equal to 1 to a, like this. So, the resultant after algebraic manipulation and taking the sum of that sum, two a cross values will be deleted and then ultimately you will get this equation. So, left hand side is the SST, that means I j k this, then right hand side the first one b n into this is SSA, that is the sum square for the factor A. Second one will be sum square for factor B, third one will be interactions and fourth one will be error. Okay. And then the degree of freedom will be accordingly broken down, that for the total number of observation is a b n, 1 minus 1 will give you degree of freedom for SST, then a minus 1 plus b minus 1, a minus 1 for A, b minus 1 for SSB, a minus 1 into b minus 1 for SSAB and AB into n minus 1 for SSE. Okay. So, this is what is the sum squares for different effects. Now, we will use some other that formula for ease of computation, because you will see that this formula here the computation will be complicated, laborious. Here the formula, the earlier the manual computation point of view as well as general computation point of view, SST can be that sum of square of all observations minus that correction factor y triple dot square by a b n. Then SSA will be the square of the rows, sum square of rows divided by the number of that values observations minus this correction factor. I am saying correction factor, this is basically correction factor for mu. Then similarly SSB, these three okay, you have got similarity earlier. But then another one is SS subtotal, which is the cell total. So, that cell total will be considered and their square sum square will be considered and will be divided by the number of such sum square in every cell 1 by n, and then it will be subtracted by correction factor, it will give you the SS subtotal. This SS subtotal will be used to compute SS interactions, which is basically SS subtotal minus SSA and SSB minus SSB. Then SSE will be calculated using subtraction method, and that is what is to be done. So, if I say how to calculate SST, you will calculate SST by considering all the observation square and take their sum minus the grand total square by n, where n equal to a b into small n. How you calculate SSA? You basically consider bn observations, then sum I equal to 1 to a y I dot square minus y dot square by a b n. So, similarly, how do you compute SSB? SSB will be 1 by a n sum of j equal to 1 to b y dot j dot square minus y triple dot square by a b n. How you calculate SS subtotal? So, this will be 1 by n sum of k equal to 1 by n y I j dot square minus y triple dot square by a b n. Then how you will calculate SSAB? SS will be SS subtotal minus SSA minus SSB. Okay. Then how do you calculate SSE? SSE will be SST minus SSA minus SSB minus SSAB. Now, SSAB is SS subtotal is this one. So, that means SST minus SS subtotal. So, this is the formula you will be using for computation. Now, once you compute the sum square, you will be going for ANOVA table. What will be the ANOVA table here? ANOVA table will be, first is sources of variation. Sources of variation. Sources of variation, one is basically with respect to, no, this is basically that sources of variation is, one is A treatment, B treatment, AB treatment, error, and then total. Okay. So, here is so big, so this should, so it should be A treatment sources of factor A, factor B, interaction AB, error and total. So, here is the we have written treatment, it is basically treatment A, this is treatment B, interaction AB, error and total, this is the issue. So, we have written rows and column, but it is not the treatment A, treatment B, treatment interaction AB. So, okay, anyway, I am showing you here, writing around here again. So, then what will be the SS? This will be SSA, this will be SSB, this will be SSAB, this will be SS error, SS total. Now, what is the degree of freedom? Degree of freedom, this will be ABN minus 1. There are A minus 1 degree of freedom for SSA, B minus 1 degree from SSB, and A minus 1 into B minus 1 will be for interaction, and AB into N minus 1 will be for error. So, this added up, subtract from this will be getting this. Then you calculate MS, that is SSA by A minus 1 is equal to MSA. So, MSB will be SSB by B minus 1, MSAB will be SSAB by A minus 1 B minus 1, and MSE will be SSE by AB into n minus 1. Then you find out F0. Here you please understand, we have three hypotheses, null hypotheses related to A, related to B, related to AB. So, F0 for A, so FA0 if I write, this will be your MSA by MSE. This follow F A minus 1 and MSE is AB into n minus 1, that is F distribution. So, similarly, MB0 will be MSB by MSE, this will follow F B minus 1 AB into n minus 1 numerator F distribution. Then F AB0 will be MSAB by MSE, this will follow F A minus 1 into B minus 1 and AB into n minus 1, this degree of F distribution with this numerator degree of F. Then what we will do basically, after that you will calculate the corresponding, you consider alpha, let consider alpha equal to maybe 0.05 or 0.01, usually these two we consider. Then find out the corresponding F alpha with required degrees of freedom and compare with the computed F0, and if the computed F0 is more than the threshold F, then you reject null hypothesis, otherwise accept the null hypothesis. So, this is your ANOVA table. Here interestingly that we have computed MS factor MSA. For example, for factor A you have computed MSA, and also for error you have computed MSE. So, if error A factor is contributing, then it is expected that MSA value will be more than expected value of MSE. Similarly, your MSB also, similarly your MSAB also. So, if these effects are significantly contributing, then their contribution should be more than the error. MSE is giving you the random variation value. So, it should not be just random like error, random variable, it should be something more. So, as a result, expected value of MSA if you compute, it is nothing but expected value of SSA by A minus 1. This quantity will become sigma square plus Bn tau I square divided by A minus 1. Similarly, expected value of MSB, it will be expected value of SSB by B minus 1. So, this will become sigma square A n sum of beta j square divided by B minus 1. Similarly, expected value of MSAB, it will be expected value of SSAB by A minus 1 and B minus 1, and this quantity will become sigma square plus n double sum tau beta I j square divided by your B minus A minus 1 into B minus 1. And interestingly, MSE, this is expected value of SSE by AB into n minus 1, that value is sigma square. So, if each of the factors are effects are contributing, then this should not be 0 for A factor, this should not be 0 for B, and this should not be 0 for AB. They should be significantly more, otherwise that they will all be equal to MSE. Okay. So, So, we will see the example what we have said in last class. Here the Y is the shelf life of a perishable product. It is stored under different temperature and pressure medium, and then we have seen that what is the shelf life, and these data are obtained based on the experiments. These are all hypothetical data, and it is basically experiment. We assume that this experiment we have conducted, and as data will be random in the sense that the experiments are conducted using proper randomization. And if this is the data, now whether this model is this model mean Yij equal to the model we have discussed earlier, whether the fixed effect model that is Yijk equal to mu plus tau y plus beta j plus tau beta ij plus epsilon ijk, this is able to explain this data or not. Okay. Primarily we are interested in tau I, these parameters, whether they are really contributing in explaining the variability of yi or not, that is the issue. So, we are using ANOVA. So, using ANOVA, we are, and ANOVA means that partitioning some squares, we are seeing this. So, let us compute this. So, what are the things we require for computation? We first require row total. So, with reference to low, the row total is 420. With reference to pressure medium, row total is 440. With reference to pressure high, row total is 429. So, there are 3 rows because pressure has 3 levels. Similarly, there will be 3 columns because temperature has 3 levels. So, column 1 total is 590, column 2 total is 381, column 3 total is 322. So, this is y I dot dot, this one is y dot j dot, another total will be cell total y I j dot, this first cell 191, second cell total 222, third cell total here like this 176. Similarly, this total, all totals are computed, and once total are known, that means you are in a position to compute the SS because you have seen the formula. Now, what is SST? SST is that sum square of all the observations. Here A equal to 3, B equal to 3 and N equal to 4. So, 3 cross 4 is 36. So, all 36 original experimental data is values are squared, and then we have taken the sum minus grand total is 1296. This is the grand total 1296, grand total square divided by ABN, that is 36. This is giving you the SST value. So, in the for SS pressure we have 3 row totals 420 square, 444 square, 429 square, and divided by Bn. So, n is 4, b equal to 3. So, 12 and minus the correction factor, it is giving you 24.5. In the same manner, temperature square sum square is 3305.17. SS subtotal, considering 1, 2, 3, 4, 5, 6, 9 subtotals are there, the subtotals are there. So, we have considered 1 by n and all those subtotals minus this is giving you this value, and then SS interaction is the subtotal minus temperature and pressure, it is giving you this value, and SSE is basically SST minus your SST is this minus SS subtotal is SS subtotal is 5620. So, this is giving you this value. So, all those values when I put here we got, and with the appropriate degrees of freedom we got that MS for pressure is 12.25, temperature is this, interaction is this, error is this, and F0 values for pressure it is very low, for temperature it is 4.68, for interaction it is 1.62. Now, the pressure and for pressure and temperature the threshold threshold f will be f, if we consider alpha equal to 0.05, f 0.0527, 27, this is 3.35, and for interaction it will be 427, so it is 2.73. So, as a result what is happening here, you see that temperature effect is significant, other effects are insignificant. So, what is our conclusion? Conclusion is only temperature effect is significant, pressure and this effect is not significant. So, this temperature factor to be controlled, and then the life of perishable good can be controlled also. So, these things we have the theory portion, and also all the conceptual things we have taken from this book. And as I already told you in the beginning that we have developed the PPT based on Montgomery book. I am sure that you are in a position now to, given a factorial experimental data set, you are in a position to conduct the ANOVA study and conclude whether what are the factors that are contributing, whether the main effects are contributing or interaction effects are contributing, or main interaction board effects contributing, and what are the effects contributing, what are not contributing. Okay. So, in next class what we will see the estimation of model parameters, model adequacy test, test of assumption, and the sample size requirement. Thank you very much.